Before watching the video, don't forget to subscribe to our channel by clicking the subscribe button below and clicking the bell icon to be notified whenever we publish a new video.
Atoms make up all of the Earth's matter. Atoms can be broken down into three basic components: positively charged protons, negatively charged electrons, and neutrally charged neutrons. The number of these components and their arrangement determines the atom's elemental properties. Here we have a helium atom. Helium atoms consist of 2 protons, 2 neutrons, and 2 electrons. The nucleus at the center of the atom is made up of protons and neutrons. The nucleus is relatively small in relationship to the rest of the atom. In fact, if an atom were the size of a football stadium, the nucleus would only be as big as a pea. The remainder of the atom's volume is made up of shells with electrons orbiting around the nucleus. While the electrons orbiting the nucleus occupy a relatively vast amount of space and comprise most of an atom's volume, they have virtually zero mass. Protons and neutrons, on the other hand, although very small, contribute most of the mass of an atom. Electrons are arranged in the electron cloud by the distance of their orbit from the nucleus. These orbital layers are also referred to as shells. Each shell can hold only a certain number of electrons. The exact number of possible electrons per shell is defined by a rule of quantum mechanics, stating that each orbit is filled when its electron count equals 2 times n squared, or 2n squared, where n is the number of shells away from the nucleus for which you are calculating the maximum number of electrons, also known as the principal quantum number. To calculate the number of electrons in the first shell, you would use the equation 2 times 1 squared, which is 2 times 1, or 2 electrons. For the second shell, it would be 2 times 2 squared, or 2 times 4, to give 8 electrons. For the third, 2 times 3 squared, or 2 times 9, equals 18 electrons. And for the fourth shell, it would be 2 times 4 squared, or 2 times 16, yielding 32 electrons, and so on. Elements may have up to 7 shells. Though each shell may not have its full allotment of electrons, this formula can be used to calculate the theoretical electron capacity for elements having a maximum of 7 shells.
Thanks for watching. If you like the video, give it a thumbs up and share it with your friends. For more tutorial and tips, subscribe the channel.